let's give it a
You
try.
can be, yeah. Hello, everyone. Yeah, we are very happy to be here. I'm Sofia.
And I'm Matteo.
Yeah. Yes. So we will share with you our work. Well, first, we are both PhD candidates at the Bioinnovation Center, and we want to share our work on bioconnected second skins, weaving the green future of smart textiles. Particularly, we want to talk about how we have been working together in a collaborative manner.
But first, a bit of background. I'm a chemist as a background. I'm working at the chemical engineer department in Aalto University, and specifically in material science.
And I am a designer. I work at the Department of Design, and I'm focused mostly on textile and interaction design.
Also here is a kind of typical day. Of course, on the left side, it's me. I'm spending most of the time in the lab, developing and functionalizing the materials that Sofia then implemented in the prototypes that you're going to see later.
Yes, and I'm mostly working all the time at the weaving studio, knitting studio, mechatronics, soldering, and making bigger scale prototypes. So we're both working on smart and electronic textiles, meaning that we're creating textiles that can, for example, sense the touch of someone or the movement of a body or the humidity levels of a room to create different things for performance, healthcare, and sports, and many other things.
But our key points are different because our researches are different. For example, for me, I mainly use an artificial intelligence approach to optimize the bio-based fibers I'm producing with the goal to substitute the current metal and metallic parts that are used in e-textiles.
Yeah, and I'm very interested in the sustainability aspects because we already have huge problem in textile industry and electronics industry. So if we combine them, we need to be careful. So it's important to integrate the life cycle approach. And for me, also creating interactive experiences, it's also relevant.
And here, just the main difference in our prototyping sessions. On the left side, it's me always. Because for me, at the moment, it's really enough to have a small prototype that works. Like, as you can see, it's a small woven textiles with a conductive yarns, and that's enough as a result to write a paper about.
Yeah. In my case, I do exhibitions. I like big-scale things. These are touch-sensitive textiles that were part of an exhibition where people could play with them to generate different sounds.
So, how we decided to collaborate? Basically, we met thanks to the Bioinnovation Center in the very first meetings, and then we had an occasion a couple of years ago to participate to this Kmart summer school. And talking about it, we discovered we were kind of lacking of each other knowledge in the sense I was a scientist, a background, so I had material science knowledge. She is a designer, she had designer and prototype knowledge, so we decided to collaborate together for the very first prototype in that summer school that is basically a CMC-based woven textile that can change color based on the pH because it contains anthocyanidins that are contained in the cabbage. So it's fully bio-based.
And then the experience was so good, we had actually great fun, and we thought, okay, maybe we can keep working together for our own PhDs and combine our knowledge and the materials we were working on. So we are combining interaction design with machine learning, weaving with material functionalization. And for example, I was working with cellulose optical fibers, Matteo was working with some triboelectric components and many more. So we thought, okay, let's bring these things together. And so today, based on what we have done so far, we wanted to share some of our insights on how actually to collaborate, what has worked for us. So hopefully it will work for some of you. So the first step is to talk, and talk a lot. And this is quite easy, because we are from Italy and Chile. We come from countries where we speak a lot. And this is important because then we realize we need to really understand our own motivations, what we mean when we talk about our research. For example, yarn, for me, was a completely different thing than for him at the beginning. So kind of just create this common language and have fun.
Then the second problem was the time perception of the processing, because For me, maybe prototyping something or just functionalizing something takes days because I need to weigh the materials, make the reaction and such. But for Sofia, maybe she's ready directly to work about it. It happens quite frequently that she has an idea and she tells me, like, can we do it? And like, of course we can. And she's like, okay, so tomorrow we can start prototyping. It's like, well, not exactly.
So thirdly, iterations and the balance of the amount of iterations that we need to do. So as we know, in the scientific method, I've learned that you have your hypothesis, you plan your experiment, you have a result, and then for me it was like, okay, we have a result, let's jump. And he was like, no, we need to try it and try it and try it again and many, many times until we know it's reliable. But for me, I was already asking if we could scale it up and maybe take it to production. So just balancing out how many trials do we actually need to move on.
Last one that is very, very important if the slide changes.
I can change it here.
Thank you.
Yes.
Okay. Is the laugh, or better, like a really open-minded and relaxed environment to work with, because we are both open-minded, we discover, so it's really easy to communicate, it's really easy to be open and let even our thoughts and feelings just flow. And for example, it happened some time ago that we were wondering which material we can use for a triboelectric project we have together. And one of those that worked quite well apparently was natural rubber. I Googled it, and the main exporter from the Google that day was UK. It was expensive, so I said, Sofia, okay, we can work about it, but well, we need to wait some days, we need to pay. And she was like, but well, actually we could even go to the pharmacy next to the department. Actually, we are working on that. So.
Yes. So easy source of materials. So what we have done so far, following these steps that we have just learned from experience, basically. But initially, well, what we're doing is basically combining these novel materials with textile structures to create e-textile systems. And the first step we had to do was to map what was happening. So we were both interested in bio-based materials to replace plastics and metals. And as Diana said, basically everything can be replaced by bio-based materials. And we found many of them, like chitosan or gelatin, agar-agar, and the most promising one was actually cellulose, because we can create sensors and actuators, the substrates, even power sources. So this was a very good example of how we could bring also material science knowledge to the human-computer interaction community and designers community. And
it was actually what we did in many of the exhibition we participated. We showed this piece that is always CMC, right, Sofia? Mm-hmm. Textile piece that works as a sensor because it's included in the conductive yarn I showed before. And for me, actually, it was a really nice experience in a sense. I'm used to make materials, functionalize them, but it was the first time I could see like people actually interacting with it and touching with it and giving their own ideas and perspective for the future.
During that same process, we also thought we were working with biomaterials that biodegrade, and they are very reactive to water. So what if we put these e-textiles into the water and we can disassemble all the components? So also thinking about the whole design process of the objects, from the material, but also to the end of life.
And as I said, last year we participated to various exhibitions, such as Dutch Design Week, Designs for a Cooler Planet, and we are planning much more for the coming year.
So currently we're working in this proof of concept of a fully bio-based e-textile keyboard to be presented in a conference in a couple of months. So this one will be made fully out of biomaterials that can be biodegrade. And for this one, yeah. And in this one, we are combining our both research, and also I invited also some other researchers from Iana's group. So here, for example, we're working in this triboelectric generator that Matteo was already working on. And then I thought, well, how can we integrate it into the system so we can generate electricity with the use of the keyboard? And there are many other components, but it's basically to create a device that people can actually use, and it helps us to speculate the future of these devices and understand how people use them, how they perceive them, how they break, etc.
So concluding, basically, we want to say that for us, we were really lucky to be hired by the Bioinnovation Center and have this chance, actually, because I see the multidisciplinarity as a personal growth, as a person and as a scientist, because it's not always easy to put yourself in other people's shoes and understand what they're thinking. So I would, and I guess we would like to suggest this kind of approach as many as you can in industry, in academia, whatever you can do it. Please collaborate.
Yes. Thank you very much.
Thank you, and come to visit our state.
Thank you so much. What a wonderful collaboration. Would you say on both of your parts that working together you sort of gain maybe some insights that you would absolutely not have gotten without the collaboration?
Yeah, definitely. Yep. Yeah, I mean definitely, because for example, in the design world, we are very eager to explore many things, but there are of course some concepts that I needed more knowledge about. What does it mean that it's biodegradable? Is this actually a better solution or not? And like considering life cycle assessments, and then understanding, okay, but how is this biodegradation actually happening? So in that sense, Matteo helped me a lot to gain more depth into these concepts and to really propose things that could really improve maybe this, and can bring my naivety to kind of in these materials at the beginning, and then I learn more, and then I can, I don't know, contribute somehow.
I would say that it's the same for me in a sense. Maybe there are things that I would have discovered in many years if I didn't meet Sofia and had this collaboration in a sense. Not just what, in my perspective, what is a functional and useful material, but for example, what people actually needs and do, let's say interaction design, as I showed before in the GIF. And that is something that, well, just staying in the scientific community is difficult to reach.
Do we have any questions from the audience? Yes.
Thank you, amazing work. And you're just a dream team, I believe. Any company would wish to have this kind of collaboration for their employees. My question is, what are you going to do after graduation?
We still have 3 more years.
Yeah, exactly.
Fair enough.
Yeah.
Thank you.
Yeah, but I mean, well, I think, I think working this way is the best way possible, actually. And I'm very grateful because in my PhD, I have 4 advisors from different schools. One of them is Jana. I don't know if she's still here or not, but they have these philosophical Mondays, for example, that I joined at the beginning. And it was so fun to just go there and everyone just talking about these issues, but from movies, culture, the impact, being critical, talking about ethical issues. So it just makes your brain work. So whatever I do in the future, I just want to keep having this kind of team dynamics. Yeah.
I actually agree. I don't have much more to say in a sense. Let's see after the PhD, but yes, yeah. I also would like to keep this kind of environment in general and be...
And the Bioinnovation wants us to make business, so let's
yeah.
see. I'm not that
Excellent. Okay, then let's continue to our next speaker. Thank you.